Hi, I'm Miss Hearn. If you like this video, please give it a thumbs up. That will help other students to find the video. You can also subscribe to my channel, Miss Hearn Mathematics, for more math videos. So looking at number 1, I want you to think about whether it converges or diverges, and if it converges, find the limit. But don't type the answer into the chat. Let's give everybody a little time to think about it. All right, so the most popular option was C, and that is correct. Very good. So if you got C, can you tell me what your reasoning was? How did you go about solving the problem?
The highest power.
That's right. So I would say that the reasoning would be that we're going to compare it to a function. The function f of x equals 2x minus 3x to the fourth over 5x to the fourth minus 6x squared. So the limit as x goes to infinity of f of x is going to be the same as the limit as x goes to infinity of the ratio of the two highest degree terms. So that's going to be negative 3/5. Okay, so that's C. All right, now let's look at number 2. So for number 2, we have what kind of a sequence? Because -1 is being raised to the n power. That's right, Jason, alternating. Very good. Okay, so I'm going to give you a hint on this one, and my hint on this one is to consider the sequence, I'll call it b sub n, that's equal to -1 over 5n minus 2, and the sequence c sub n, which is equal to 1 over 5n minus 2. So it's a two-part question, right? First, does it converge or not? And if it does converge, what does it converge to? So think about that for just a minute. And think about our different tools that we have, right? So we have different theorems. Like, for example, we know all of these facts that we could use. And we've discussed this fact here. I said that one comes up a lot. And just the general limits of functions rules that we know from before. So amongst all those things, think about what might help you to solve this problem. The sandwich theorem is another one. So we have a very split decision here. The most popular choice was C, and that's actually correct. But it was pretty close. Only 5 people selected C, 4 selected A, 4 selected B, and 1 selected D. So let's take a look. If you chose C and you were pretty confident in your reasoning, can anyone share with us what you were thinking, why you thought C might be the answer? Any ideas you can share? Okay, well, for the B sub n and the C sub n, I agree with you. These are definitely going to 0 because as n goes to infinity, the numerator is constant, it's fixed, and the denominator is going to infinity. But not for A sub n. For A sub n, it's alternating, right? It doesn't stay constant. It goes -1, 1, -1, 1, -1, 1, -1, 1. So you can use that reasoning for B sub n and C sub n. How do we then translate that to help us with A sub n? What do we know about A sub n that lets us know that if those two are going to 0, then that one has to go to 0 as well? That's right, very good. The sandwich theorem is one way we could rationalize this. So we would say B sub n is always less than or equal to A sub n, and C sub n is always greater than or equal to A sub n. So since B sub n goes to 0 and C sub n goes to 0, by the sandwich theorem, A sub n must go to 0 also. So that's why C is correct. So what's actually happening here is one of the sequences, the C sub n's are positive. They're going down towards 0. The B sub n's are negative. They're going down up towards 0, actually. The A sub n's are alternating. So it's this guy and then 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 this guy, right? It's alternating, but still it's getting closer and closer. Although it's going back and forth, each time it goes back and forth, it's staying closer to 0. You could also use the fact up here, which was proven using the sandwich theorem. This, you could call it a corollary of the sandwich theorem, which says that if you can show that the absolute value of each term of the sequence, if you think of the absolute values of the terms of the sequence as their own sequence, if that sequence goes to 0, then the original one does too. We actually have that down here as well, because isn't it true that the C sub n's are each the absolute value of the A sub n's? So since the C sub n's go to 0, that means that the A sub n's go to 0 as well. So that would be another way to think about it. Okay, so the next problem on sequences, we are looking at 9.1.72 from your textbook. We're still trying to determine if this sequence converges or diverges, but it's a sequence that involves factorials. I know not everybody's seen factorials before. So one of the things you're going to need to do with factorials often is to simplify them by writing them out long ways. So what I mean by that is, for example, if I asked you to simplify 3 factorial divided by 5 factorial, if you think about this as 1 times 2 times 3 over 1 times 2 times 3 times 4 times 5, then you can see that the 1s, 2s, and 3s cancel out, and you're just left with 1 over 4 times 5, or 1/20th. But most of the time when we do that in this class, not always, but most of the time, it's going to be with variables. So here we have our sequence, our nth term of our sequence is defined to be n plus 1 factorial over n plus 3 factorial. So I'm going to, before I even try to figure out what the limit, if this has a limit or not, I'm going to just see if I can simplify this a bit. So this is in the numerator, n plus 1 factorial is saying multiply all the numbers up to n plus 1. So that would be 1 times 2 times 3, etc., all the way up to n, and then times n plus 1. And then in the denominator, we have all of those terms plus a couple more, right? Because it goes all the way up to n plus 3. So we're going to go 1 times 2 times 3, dot, 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 all the way up to times n plus 1 times n plus 2 times n plus 3. So all of the common factors are going to cancel out. We can divide them out, and it's going to leave a 1 behind. So a simpler way of writing the nth term of this sequence is going to be 1 over n plus 2 times n plus 3. So that's something you're going to need to get comfortable with, is simplifying expressions with factorials in them. All right, now that we have it written in this format, what do you think? Do you think that's the sequence is going to converge or diverge? In other words, do you think there is a limit as n goes to infinity, or no? Okay, Sierra thinks it converges. I agree. What do you think it converges to? 0, that's right. So if we try to take the limit as n goes to infinity, and I need to make myself some space here. The limit as n goes to infinity of 1 over n plus 2 times n plus 3, the denominator is going to increase without bound. It's going to go to infinity, but the numerator is fixed. So 1 divided by infinity is going to give you 0. So we can say that the A sub n's are going to converge to 0. All right, so that's a type of problem that will come up in your homework. So make a note of that. When you got the factorials, simplify as much as you can. Here's another type of problem that might come up. So we have a sub n equals the nth root of 5 to the n times 4 times n over 2 times 7 times n. So again, simplify as much as you can. For example, 2 goes into 4 twice. And also, whenever you have two values, one in the numerator and one in the denominator, that both have the same power like that, sometimes we can put those together and it might be helpful. Just, don't be afraid to try different things as well. So here I'm going to say, well, let's see, the nth root of, I'm going to think of this as 5 to the n over 7 to the n times 2n. And see what I can do with that. Well, when you have a product, you can break it apart. So we have the nth root of 5 to the n. Actually, I'm going to think of this as not 5 to the n over 7 to the n, but 5/7 to the n would probably be better. Because then when you take the nth root of an nth power, they cancel each other out, right? And then nth root of 2n. So this is going to be 5/7 times the nth root of 2n. That looks a lot easier to work with. Okay, so now we have to look back at our common limits and see which of those 6 rules are going to work, if any, for this. So jot this down, 5/7 times the nth root of 2n. And let's go back up here and look at these 6 rules in Theorem 5. Do you see any of these scenarios popping up? Are any of these rules going to be helpful? Okay, do any of these rules look like they would be helpful for number 3, now that we have it written as 5/7 times the nth root of 2n? How about if I write it like this? How about if I write it like 5/7 times the nth root of 2 times the nth root of n? Which rules look like they fit now? That's right, 2 and 3. 2 and 3 look like they're going to fit. Both of those say that n is going to infinity, means that x to the, or in this case, 2 to the 1 over n is going to 1, and n to the 1 over n is going to 1 as well. So that would mean that a sub n is going to go to 5/7 times 1 times 1. I should not put an equals. I should put an arrow there. That means that I'm taking the limit as n goes to infinity. So that's going to be just 5/7. So this sequence converges to 5/7. Okay, now let's, any questions about number 3? All right, how about number 4? A sub n equals n factorial over 10 to the n. Do any of these rules look like they could give us any insight regarding this problem? It might not fit exactly, but it might give us some insight. At least to know if it converges or diverges, right? Does any rule have some similar expressions in it? Yeah, Rule 6 does. What's different from Rule 6 to Rule between Rule 6 and the problem we have, though? Compare this expression to this expression. They're switched in what way? They're reciprocals, right? So if we had the sequence, let's call it b sub n equals to 10n over n factorial, Rule 6 would tell us that's going to go to 0, right? Rule 6. All right, but we don't have that, but we have something related to that. Could that help us to draw a conclusion about a sub n? How about if I write a sub n as 1 over 10 to the n over n factorial, so that we can make a direct comparison there. So as n's going to infinity, what's happening to this denominator? It's going to 0, that's right. And so if the denominator is going to 0, but the numerator is fixed, then this whole thing must be going to what? If you divide 1 by a smaller and smaller and smaller number, the quotient is going to get infinite. That's right. 1 divided by 0, that's going to infinity. So actually, a sub n diverges. Okay, and then another type of problem that you might see is something like this. So we know that from, let me remind you of rule number 4 here. Rule number 4 says the limit as n goes to infinity of x to the n will be 0 as long as the absolute value of x is less than 1. Because when you raise a fraction, what's happening there, let's say that x is 1/2, right? Then the terms are going to be 1/2, 1/2 squared, 1/2 cubed, and so on. So you get 1/2, 1/4, 1/8, 1/16, and so on. They just keep getting smaller and they go to 0. So what does that have to do with our problem? Well, in 3 of these terms, we have 3 terms, and in 1 of these terms, we have a number less than 1. The absolute value of 9/10 is less than 1. So we know that 9/10 to the n power is going to approach 0, but we have a problem with the other 2. 12/7 absolute value is definitely not less than 1. 5/2 absolute value definitely not less than 1. So there's a little trick that you can do to get them to where they are all less than 1 sometimes. And that is to multiply by the reciprocal of one of the terms in the denominator that's greater than 1. So if you look in the denominator, only 5/2 is greater than 1. So I am going to multiply by 2/5, it's reciprocal, to the n power in the top and the bottom, numerator and denominator. And if we do that, we're going to get 24/35 to the n. Notice that's a number less than 1. And we're going to get 18/50 to the n. And we're going to get 1. 1 to the n, which is 1. All right, so now as n approaches infinity, rule number, what was it? 4? Yeah, rule number 4 applies because the base is a positive number less than 1. So this guy is going to go to 0 by rule number 4. And this guy is going to go to 0 by rule number 4. So we're going to get 0 over 0 plus 1, which is going to be 0. So a sub n converges to 0, and we're done. I hope you found this video helpful. If you did, please give it a thumbs up. That will help other students to find the video. You can also subscribe to my channel, Miss Earn Mathematics, for more math videos.